We've already seen how to factor out a greatest common factor. Occasionally you're given a problem to factor that requires you to do two operations. First, factor out a greatest common factor, and second, use the reverse FOIL procedure to finish the factoring. And this is an example that falls into that category. The first thing you want to do when you're asked to factor an expression is to take a look at each one of the terms and see if they have a common factor. If they do, factor it out first. It'll make your work considerably easier. Now in this case, notice I have a 6 times x squared, and I have subtracted from that a 6 times 1. So there's a common factor of 6 in each one of these terms. I'm going to factor out that common factor 6, and I'm left with x squared in the first term minus, when I take the 6 away, I'm left with a 1. So my greatest common factor is 6, and I'm left with this quadratic in parentheses. Now, this quadratic doesn't have a middle term. However, it can be factored. The 6 is going to sit there and watch the rest of the problem. I'm going to draw a double set of parentheses. And the remainder of my work is going to be to factor this expression, x squared minus 1. Well, I know by the FOIL rule, first times first gives me x squared. My job now is to try to come up with a pair of numbers that multiply to give me -1, but add to give me, there is no middle term. There's no x term. The reason there's no x term is because its coefficient is 0. So if you think of 0x in the middle here, then I'm looking for two numbers that add to 0 and that multiply to -1. Well, the combination of numbers is not that big. 1 times a -1 gives me -1, multiplies the -1. And 1 added to a -1 gives me 0. I have my numbers. I'll write a +1 in this position and a -1 in the second position. And just taking a look at this factoring here, when I FOIL it, it checks. X times x gives me x squared. Outer is -1 times x. Inner is +1 times x, which cancel out to give me no x's. And 1 times a -1 gives me a -1. Now, this particular form here is called the difference of two perfect squares. Notice that the first term is a perfect square, x times x. And the 1 is a perfect square. It's 1 times 1. And there is a negative in the middle. Now when you see this form, perfect square, subtract a perfect square, then to factor it, you have x times x. They give you x squared. X is in the first position. And in the second position, I have 1 times a 1 gives me 1, positive. Well, the two signs have to be opposite signs. Now, to give you a second example of this, suppose we have x squared minus 9. This is a difference of two perfect squares. I'm going to draw a double set of parentheses. The first perfect square is x squared. So I write x in the first position, x in the second position. X times x gives me x squared. 9 is a perfect square. 3 times 3. I write 3 in the two last positions. I make one positive and the other negative. And when I check, x times x is x squared. Negative 3x and positive 3x cancel out. There's no middle term. And 3 times a negative 3 gives me a negative 9. Okay. Let's return here. Notice I have 3 factors in my final answer. I have x plus 1, x minus 1, and I have this constant factor 6. Let's see you try one. I'd like you to factor the following. 8m squared minus 32. I'd like you to pause the tape. Notice you have a greatest common factor, which you're going to take out first. You're also going to use reverse FOIL afterwards. When you think you have the answer, turn the video back on, and we'll go over it.